Okay, section 8.3, the product and quotient theorems, referring to the complex numbers in polar form, come up with some rules or some properties on how we can multiply and also divide those numbers. So here we have two complex numbers in rectangular form, and let's go ahead and multiply these together by using the FOIL method. So 1 times negative 2 root 3 would be negative 2 root 3. Outside term, 1 times positive 2i is a positive 2i. Inside terms, positive times negative is negative. We're going to have 2 times I. Root 3 times root 3 is 3, so that all becomes a 6i. And last times last, positive I root 3 times positive 2i would be a positive 2i squared root 3. 2i squared times the square root of 3. And recall that I squared is the same thing as negative 1. So what we currently have, negative 2 root 3, 2i and negative 6i make negative 4i. And this becoming a negative 1 creates a negative 2 root 3. So one more like term, right, to combine negative 2 root 3, negative 2 root 3, make negative 4 root 3. So we have negative 4, let's write the real part first. We have negative 4 root 3 right here minus 4i. And if you take negative 4 root 3 minus 4i, now that's the rectangular form of a complex number. If by using the previous section, if we were to take this guy and convert it to polar form, negative 4 root 3 minus 4i is the same thing as, I'm going to write it in red, 8 cis 210. So all I did there was take this guy that's in rectangular form and convert it to polar form. Now let's go back and take each individual factor. Let's take each of these guys and let's convert them to polar form. So the first one was 1 plus I root 3. And if you convert that guy to polar form, 1 plus I root 3 is the same thing as 2 cis 60 degrees. And the other factor that we had was negative 2 root 3 plus 2i. And if we convert that one to polar form, we get 4 cis 150. And what did we do up top? We took these two guys in rectangular form, multiplied them together, and we got negative 4 root 3 minus 4i. So the product of those two was negative 4 root 3 minus 4i. And when we converted that one to polar form, we get 8 cis 210. So do you see a pattern here as to how I can take two complex numbers in polar form, multiply them together to get the answer? You see a pattern that if I take the two r values, multiply them together, I get the r value of the product, and if we add the two angle measures together, we get the angle measure in the product. So the theorem says if you're going to multiply two complex numbers together in polar form, multiply the two r values together, and then also add the two angle measures together. So our example says find the product of 3 times the quantity cosine 45 degrees plus I sine 45 degrees and 2 cosine 135 degrees plus I sine 135. Let's write those in shorthand. This would be 3 cis 45, and we want to multiply that times 2 cis 135. So using our new property, that product would be 3 times 2, or 6. Cis 45 plus 135 would be 180. So we can actually simplify this one a little more. Why? Because 180 degrees is a special angle. So let's write this out in unabbreviated form. This would be 6 times cosine of 180 plus I sine 180. And just to clarify, this won't always happen. You won't always end up with a special case angle here, but if you do, you can continue on. Had this been something like 97 degrees, you can stop right there and circle your answer. So we have 6 times the cosine of 180 degrees is -1. So we have -1 plus I times the sine of 180, and the sine of 180 would be 0. So this would be a -1 plus 0 times 6. Final answer, -6. Here we have the quotient theorem next, and it behaves similarly to the product theorem. So if we're going to divide two numbers, two complex numbers in polar form, then instead of multiplying the r values, notice we divide the r values when finding the quotient. And also, instead of adding the angle measures together as we did with the product theorem, with the quotient theorem, we simply subtract the angle measures. So in abbreviated form, r cis theta of one complex number divided by r cis theta of another complex number, simply divide the r values and subtract the angle measures. So the example says, find the quotient 10 cis -60 degrees divided by 5 cis 150. Write the result in rectangular form. So we go ahead and divide the r values. 10 divided by 5 is 2. And we'll have 2 cis -60 minus 150. So this would become 2 cis, this would be a -210 degrees, and we should convert that to a positive value. So -210 degrees is the same thing as +150 degrees. And the directions say write the final answer in rectangular form. So using methods in the previous section of converting a complex number from polar form to rectangular form, you'll get the solution -√3 plus I.